Today we're going to learn about how to draw the transitional diagram of cosmology. We're trying to answer the question of where new solar systems come from. Now, in order to do that, we're going to start by situating the centroid. That means we're drawing a two-dimensional lattice like the familiar Cartesian plane, and that's our starting point on the diagram. Next, we're going to draw concentric circles around the center. I've done 5 here. Next, at a 45-degree angle to the x-axis, we're going to introduce the first exclusion event. So that means mass is going from the very center to just adjacent the center. It's got particular velocity at that point, as well as an associated mass. That velocity on its own is linear, but because it's in the gravity field of the object that excluded it, it doesn't look like a line when we go to observe it. Continue that path on the shape of the circle for another 90 degrees. And we're going to map the next exclusion event there. We're going to continue this throughout the 5 layers that we've drawn. At every 90 degrees, we introduce another exclusion event. Next, we're going to come to the more complex portion, the most difficult portion of the drawing here, and that's to get the pure form archetype just right. It has to connect all the points on the path of your excluded object. And so you're trying to get it as smooth as possible, always going through all of those points. So that takes a bit of practice. It's important to appreciate that this is the most technically challenging portion. So to perceive the entire shape as one entity is going to get you the smoothest rendering. And the next path we're going to draw is the real path, which actually includes the quantum state exclusions. That's a lot easier because it's always going along a circular path. So when we go to observe this, this is actually the path we would expect to see, where there's those finite, discrete, exclusionary bands. The circles are just a backdrop to help bring out the image of the contrasting pure form and actual paths.